Hey y'all, welcome to your first day of e-learning. This is going to be super fun. This unit is going to be over area, and we're going to just take it basically shape by shape and talk about area of triangles, parallelograms, trapezoids, all types of stuff. So today we're going to focus on area of triangles and parallelograms. And so the area of triangles, you already know a lot about that, but the formulas that we mainly use are going to be that 1/2 base times height or base times height divided by 2, whichever one you like to use. I'll tell you all what I like to use is the second one a little bit more because if I have to solve anything algebraically, it makes a little bit more sense to me that way. But it's up to you. There's going to be a couple of other formulas you're going to want to know. Of course, these would have been things you would need to have memorized, but since we are now doing everything online, you're going to have access to it. So make sure you get this written down and that you know where to find it because you're going to need it. So then the next formula, it's called Heron's formula. Heron's formula. And you're going to use Heron's formula when you're given the three sides of the triangle. So when you're given the three sides of the triangle, this is the formula that you're going to use. So I'm going to give it to you and then I'll explain it. So the formula is the square root. We're going to do the square root of a lot of stuff. So it's going to be S times S minus A times S minus B times S minus C. It's actually a pretty easy formula. You just now have to know what S means. And so S you get from doing A plus B plus C, and you do it over 2. Okay, and A and B and C, those are coming from your three sides. So you add all three sides up, divide by 2, and then you just plug it into that formula, and it's very easy. The next formula that you're going to use a lot is when you have an equilateral triangle. So you can do this, you can actually do the formula, the base times height over 2 for an equilateral formula. It's just a little bit more, or for an equilateral triangle, it's just a little bit more work. So if you have this formula, S squared square root of 3 over 4, that makes getting the area of an equilateral triangle a lot easier, even though you can still use your base times height over 2. Okay, so those are all the formulas for area of a triangle. Area of a parallelogram is going to be area equals base times height. That might just look a little bit different depending on what your shape looks like. So if you look at this parallelogram here, you can see here's my base and here's my height. If you look at this parallelogram down here, which mine was kind of cut off, you can see that the base is down here, but the height had to be drawn in because it needs to be perpendicular. And so that's what this is out here. Whereas the one above it, that height was already drawn in. So that height could come from a couple of different places. So we're just going to do a lot of problems, basically. So this first example says find the area. Okay, so we need to get the area of this funky looking figure here. There's always a few different ways of doing this. You could cut these into a lot smaller pieces if you were able to. I'm going to try to take the whole thing and kind of cut out this piece here that we don't want. It's just what looks visually the easiest to me. But there's never sometimes there's probably just one way to do these, but a lot of the times there's multiple ways. And so what I like to do is I kind of like to get more specific with this. So I'm going to say I've got the big rectangle and I've got the small rectangle. And for the big rectangle, I need to take the base, which is 8, times the height, which is 6. So the big rectangle would be 48. And then I'm going to look at the small, and the small is actually, technically it is a rectangle, I guess, but it's also showing me all these sides are equal. So it's actually a square. So I just need to figure out what that side's going to be. Well, the whole thing here I know is 8. This piece is 3, this piece is 1, which left over means this is 4. So if I do base times height of the small rectangle, 4 times 4 would be 16. So if I want to figure out what's left, I'm going to subtract those. And 48 minus 16 is 32. I'm going to try to get better about putting all the units down. So since we're talking area here, we're going to be units squared. I will probably forget to do that on something. The next one, find the area of triangle ABC. So I'm just going to identify, make sure I know what triangle it's talking about here. So ABC, that's this triangle here. Okay, well I can see that I have the base. Now just be careful here because I don't want 11 to be my base. I just want the base of that triangle. So this is base times height over 2. And so my base here I know is 8. And I don't know my height. Okay, so you can see here our height was drawn in. We just need to figure that out. So I look at this triangle, and I can see I have 3. I need to know this leg, and then I have 5. Okay, you can do Pythagorean theorem if you want, or just know that this is a 3, 4, 5 triangle, and so my height is 4. So 32 over 2 would be 16. We're talking area, so units squared. Okay, the next one, find the area of a square, and it gives you these 4 coordinates. So notice it does say that this is a square. Okay, which means all these sides are going to be the same. I don't know the distance between these 2 points. If I had the same x value somewhere, the same y value somewhere, I could probably just figure it out, but I don't have that. So I'm just going to choose 2 of these points. And unfortunately, we have to get the distance. So I'm going to say distance equals, I'm going to take the square root, I'm going to subtract my x values, and I square it, subtract my y values, so that'd be 1 minus a negative 1, so that's 1 plus 1, and I square it. Okay, when you do all of that, you actually end up with the square root of 13. Remember as we're doing all these videos that you can always stop and start and rewind and do whatever you want with these. So be really smart about that. If I'm skipping a step or something. So here, for area of a square, you can either think of base times height, or you can think of side squared. And so here, well, my base and height are going to be the same. So square root of 13 times square root of 13 is going to be 13. That would be units squared. So that is my answer here. This next one, find the area of the region bounded by these 3 lines. So I'm going to graph these 3 lines first. Okay, so the first line is y equals 0. Okay, that's going to be a horizontal line going through 0. The next line says y equals 5 over 2x plus 5. Okay, so I'm going to start at 5. And my slope's 5 over 2. So that line is going to look like this. And then the next line says y equals negative 5 over 3x plus 5. So again, we're starting at 5, and then I'm going to go down 5 over 3. And so our other line looks like this. And so the triangle that we want to get the area of is this one. And so area of a triangle we know is A equals BH over 2. And so my base, I can just count my base because I have this horizontal line. So I've got 1, 2, 3, 4, 5 is my base. For my height, I just need that perpendicular. I need that 90 degrees. So here's my height. And again, I can just count that. And so that would be 1, 2, 3, 4, 5 also on my height. And if you do 5 times 5 over 2, that's 25 over 2, which is 12.5 units squared. Number 5, find the area of a triangle whose has side lengths of 4, 8, and 10. Okay, so remember, if you're given the 3 sides of a triangle, that tells you you're going to use that Heron's formula. So for that, I need to find what S is first. So I'm going to take 4 plus 8 plus 10, and I divide it by 2. And that's going to get me S, okay, which is 11 if you do all of that. Okay, and now I'm going to take that and I'm going to plug it into the formula. So we have area equals, I'm going to take what S is, which is 11, and then I'm going to do 11 minus that first part, the first side, which is 4, and then 11 minus the second side, which is 8, and then the last side, which is 11 minus 10. That part, I probably wouldn't write all that out. I'd probably do those pieces in my head, but for this, I'm just going to write it all out. If you multiply all that together, you get 231. There aren't any perfect squares in 231 that I know of, so that's it on that one. The next one, find the area of an equilateral triangle. Again, I'm going to use that formula of sides squared, square root of 3 over 4. I could do this by doing base times height, but you would have to draw in your height. And then you start thinking about having to do Pythagorean theorem or 30, 60, 90 triangles. And if I can just use this formula, it's a lot easier. So if the perimeter is 24, each side is 8. So that'd be 8 squared, which is 64, square root of 3 over 4, and 64 divided by 4 is 16. So 16 root 3. Number 7, given the parallelogram, find x. So notice where x is. X is the height, but if x is the height, then the base is 12 that goes with that x. Okay? So the problem is, to be able to find x, that would mean I would probably need to know the area, and I don't know that yet. But let's see what other information they give us. They give us that this height is 6, and this base is 18. So I can find the area. So area equals base times height. So that's 18 times 6, which is 108. So I do know that the area of this whole parallelogram is 108. Okay, well, if that's the case, now I can use what I put over here in green. I can use that height and that base, and I can just re-plug it into the formula. So the area I now know is 108 equals base, which is 12, times height, which I don't know. Divide both sides by 12, and so the height is 9. So that's one way of doing it. Another way of doing it is you can look at your 2 triangles that you have. So we have this triangle here, which is a right triangle, and we have this triangle here, which is a right triangle, and we can set up similar triangles here. So I could say 6 over, if this side's 12, I know this side's 12. So I could say 6 over 12 equals this height, which is 9, over 18. Sorry, it's not 9. We don't know that yet. Is x over 18. And then you cross multiply and divide, and you still get 9. So either way, similar triangles, or just use the formula again. Just a couple of extra practice problems here, just using some more Algebra 1 skills. So here, base times height, so it'd be 5x to the 6 times 3x cubed. So it'd be 15x to the, if you're multiplying, you add the exponents. Here, base times height, so it'd be 2x minus 3 times x plus 3. You would FOIL, so 2x squared plus 6x minus 3x minus 9. So it'd be 2x squared plus 3x minus 9 units squared, or whatever. I didn't do that on the last one. I don't really need to. Alright, the next one. A rectangle's area is 18x to the 4th y to the 3rd, and its height is 3xy squared. Find its length. So if you think about area of a rectangle, it is base times height. But notice here they're using the words height and length, so I'm going to use that. Okay, so if we actually here want to find the length, then I would need to divide both sides by the height, and that'll get me the length. So I'm going to take the area, and I'm going to divide it by the height. So I'm going to do 18 divided by 3 is 6. X to the fourth, and when we're dividing, remember you subtract exponents. So that would be x to the third, and then y cubed over y squared would leave me with just y. Number 4, a square's area is 49x to the fourth. Find its side length. Okay, so 49x to the fourth. So here is where the formula of area equals side squared would really come in handy, because now I'm just going to plug in what I know. So 49x to the fourth is the area. And if I want to find s here, I would need to take the square root. So I just need to take the square root of that. So square root of 49 is 7. The square root of x to the fourth is x squared. So that's the side length. Number 5, just another equilateral triangle example of if each side, the perimeter is 12 meters, which means each side would be 4 meters. So if I plug that into the formula, area equals 4 squared square root of 3 over 4. That would be 16 over 4, which is 4 root 3, and this is meters squared. Find the area of triangle ABC. Okay, so I've got triangle ABC. That is the whole thing here. And so to be able to do that, I need to know the base and the height. Well, I know the height is 8. I do not know the base. I know part of the base is 6, but I don't know the whole thing. So you first need to figure out what that is. To do that, you can do Pythagorean theorem. This is also a triple, so I'm just going to use that because I know that, which means this whole side is 15. That would leave this piece that's missing. That would mean that that's 9. So if I now want the area, of course I don't really need to know that piece right now, I guess, but I did have to know the whole thing was 15. So I'm going to do area equals 15 times 8 over 2, which when I do that, that gets me 60 units squared. Okay. Now this next question says, what is the measure of angle ADC? That would be this angle. Whoops. That would be this angle right here. Okay. And think about in the last couple of units, anytime you had to find an angle, you had to do inverse trig. So you had to do inverse sine, cosine, or tangent. Well, here, this is not a right triangle. So yeah, you could do law of sines or cosines, or we could find the other side of it. So this piece here. And then we know that the purple and that red angle are going to add up to be 180. So that's what I am going to do. Okay, so what I'm going to look at here is if I want to find this purple angle, I have my opposite and adjacent side. So I'm going to use inverse tan here. So I'm going to say tan of x equals opposite, which is 8, over adjacent, which is 15. And then, of course, in the calculator, I'm going to type in tan to the negative 1, 8 over 15. Make sure that your calculator is in degree mode if you're going to do that. Okay, and then I'm going to just keep that number in my calculator, and I'm going to do 180 minus this. And when you do that, you get about 126.87 degrees for the red angle. Because that other number, I don't have it in my calculator right now, but had to have been something like 52 point something-ish. Just did that in my head, so could have been wrong. All right, here we go, last slide. Determine the area and the perimeter of the following figures. Okay, so here we go. You see that 45. You know what that means. Okay, so we need to get the area. Okay, so to get the area, we need to do first base times height, because this is a parallelogram. Okay, well, the base, we know, is 17. It's the height that we don't know right here. Okay, but since this is a 45, 45, 90, we know that that height is going to be 9. Okay, if you need to go back and review your 45, 45, 90s, then do that. I'm not going to spend a lot of time talking about it. So this is 153. That would be yards squared. So there's my area. Now perimeter, we're just going to add up all the sides. Well, I know that this whole side here is also 17. We just need to find this side here. Well, since this is a 45, 45, 90, this is my x root 2 side, which means that is going to be 9 root 2. Which means the side opposite from it is 9 root 2. So the perimeter, I'm going to do 17 plus 17, which is 34. And then 9 root 2 plus 9 root 2 is 18 root 2. You cannot add those together like this. If we want to keep it as accurate as possible, as exact as possible, you leave it. If we ask for the decimal, then type it in. Okay, number 8. So here, again, I need to get the area and perimeter. Well, the area, again, is just going to be base times height because it's a parallelogram. Okay, well, I can see the base here is 32. But, again, we need to find the height. So this is a 30, 60, 90 here. This 12 is going to be my short side, so that's my x. The height is my x root 3, and the hypotenuse is my 2x. Okay, which means if x is 12, that means my height is going to be 12 root 3. If I multiply that, 32 times 12 root 3, that is going to be 384 root 3. Okay, if I want to get my perimeter, I just need to do 32 plus 32, which is 64. And then I need to find this other side. So if x was 12, then that means these two sides were 24. So that's 64 plus 48. And 64 plus 48 is 112. Okay, and that would just be meters, and our area would be meters squared. All right, I'm going to look at these next couple and see if I feel like I need to do them. Let's go ahead, and we are going to do, if we just do one of these, I think y'all will get the other one. So let me just do number 10, and we'll get wrapped up here. Okay, so notice here we kind of have a funky looking angle. It's not a 30, 60, 90. It's not a 45, 45, which probably means you're going to need to use trig. Okay, and so here, if I want to get the area of this parallelogram here, I have the base, which is 12. We just don't know that height. Okay, we need to find it. So I'm just going to put an X over here so that I can figure out what that height is. Okay, and so I see what I got. I've got my opposite, and that's my adjacent. So I'm going to do tan of 35 equals my opposite, which is 4, over my adjacent, which is x. Remember this, I know Mr. Hazip maybe teaches this a little bit differently to do a proportion. So you can either do that, or I know my class I taught that if x is in the denominator, remember you can just flip these two things when you type it in. So when you do that, you end up getting x as about 15.71, I believe. And so I'm going to put that in for my height. So if you do times 12, you get about 68.55. I maybe just went off or something on these numbers. I may have rounded differently or whatever. Now, if I wanted to find the perimeter, I'd have to do the same process, except I would need to find this piece so that I could add it. Okay, so you would just do 12 plus 12 plus whatever you get here is going to be there, and then you add it. All right.